If we increase the scale yet again by a factor of 100, we see in the same viewing field all 4 inner or terrestrial planets revolving around the sun. They are Mercury, the one closest to the sun. Its distance from the sun is about 0.4 astronomical units. Then Venus, with a distance of just over 0.7 astronomical units away from the sun. Then the Earth at 1 astronomical unit, and Mars at 1.5 astronomical unit. These 4 planets are known as terrestrial, meaning Earth-like planets, because in Latin, the Earth is terra. So here you can see the orbits of all 4 planets around the sun, but they are not perfect circles. They are slightly deformed circles. In fact, the planetary orbits are elliptical in shape. An ellipse is a deformed circle, and the amount by which an ellipse deviates from circle is characterized by a number called eccentricity. So Mercury, the one closest to the sun, has the highest eccentricity of about 21%. Then Venus has much smaller eccentricity. It deviates from a perfect circle by only 0.7%. Then the Earth, its orbit has eccentricity of 1.7%, as I discussed earlier when I talked about variations in the distance between the Earth and the Sun over the year. The eccentricity of the orbit of planet Mars is about 9%. And in addition to these 4 terrestrial planets, there are also orbits of 2 other bodies indicated here. This one here is the orbit of asteroid Icarus, which belongs to the group of so-called Apollo asteroids. And these asteroids actually enter the inner part of the solar system and potentially could be a threat of colliding with one of the planets, including the Earth. And you see that in the case of this asteroid, the orbit is highly elliptical and the eccentricity is large. It's 83%. And in addition to the orbit of this Apollo asteroid, there is also a segment of the orbit of probably the best known comet, so-called Halley's Comet, which comes around the sun once every about 75 years. And the eccentricity of its orbit is even higher. It's about 97%. Eccentricity, by definition, is a number that ranges from 0, corresponding to the perfect circle, and any number less than 1. So as you can see, the orbits of these Apollo asteroids and also of comets have much higher eccentricity than the orbits of planets around the sun.